So in this chapter, we're going to be talking about solutions. And so the first thing we have to do is actually define what a solution is. Okay? So a solution is a homogeneous mixture. And so by homogeneous, remember, we mean the same throughout, evenly distributed. So for example, if I take water and I add salt to it, if I just allow the salt to settle on the bottom of the water glass, then you're going to have a heterogeneous mixture. It's not the same throughout. So what makes a homogeneous mixture is the fact that your salt ions, the sodium ions and the chloride ions, are evenly distributed throughout the water itself. So that's a solution. Now, to define a solute and a solvent, because these are terms we're going to be using throughout this chapter, the solute is the salt. It is what you actually dissolve into the solvent. Okay? So it's going to be dissolved in the solvent, which makes the water your solvent. So the solvent is what actually dissolves the solute. So the solute is your salt, solvent is your water. So now we have three more terms that we have to talk about, which include saturated solutions, unsaturated solutions, and supersaturated solutions. Okay? So based on the activity you just completed, you should be able to come up with definitions for each of these, but let's just make sure we're on the same page. So a saturated solution is a solution that contains all the solute that it can possibly dissolve. So if you were to add more to a saturated solution, more of your solute, no more would dissolve. It would simply sink to the bottom. You couldn't add more solute. You couldn't dissolve more solute. Okay? So a lot of the time you reach this point when you're mixing, for example, if you were to mix hot chocolate into water. At a certain point, you've added as much solute as can be dissolved, and then past that point, you're just going to end up with solid on the bottom. Now, before you hit that point, if you have an unsaturated solution, that is a solution that does not contain the maximum amount of solute. So an unsaturated solution would be a solution that can still dissolve more solute. Now a supersaturated solution is a solution that contains more solute than the solubility allows. So how exactly do you get to that point? Well, if you heat up water, for example, and stir in your solute, if you heat it up really, really, really hot and then allow it to slowly cool off, the solute particles can actually be tricked into staying in your solution and not becoming solid again. And as a result, you're going to have this syrupy consistency because you have more solute dissolved than really should be. And so that's what a supersaturated solution is. So we're going to quickly talk about a couple of factors that affect solubility. And the first one is agitation. So if you're trying to dissolve a solid into your solvent, if your solute is a solid, then if you increase the agitation, meaning if you mix it, you're going to increase the solubility of that solid in your solvent. So when you're making hot chocolate, for example, you take the hot cocoa powder, you dump it into the water, and then you don't just leave it. You stir it. That's agitation. The second factor is temperature. Okay? So if you increase temperature versus if you decrease temperature. If you increase temperature, then the solubility of a solid is going to increase. So if you think about it, when you're making hot chocolate, the reason why we call it hot chocolate is because we want to increase the solubility of the solute, your cocoa powder, into your water or your milk. And so if you increase temperature of the solvent, then the solute is better able to dissolve. In contrast, if you decrease the temperature for a gas of the solvent when you're trying to dissolve a gas, that increases the solubility. So if you think about it, if you have ever had soda in your life, the best type of soda is cold soda. And that's because the gas is able to stay dissolved in the water better than if it were warm, because once you start to increase temperature, the solubility of a gas in a liquid decreases. So you start to lose your carbon dioxide bubbles and it suddenly becomes flat. So that's why we leave open bottles of soda in the fridge, just to encourage the gas molecules to stay dissolved in the liquid. Okay? And so now what you guys are going to do is you're going to use your textbook in order to look at some of the quantitative ways of representing solubility and concentration.